So starting from chapter 16, we will talk about carbonyl containing compounds. The compounds with CO double bond, which is called the carbonyl functional group. This includes aldehydes and ketones. For aldehydes, there will be one hydrogen attached to the carbonyl. For ketones, there are two carbons attached to the carbonyl. Carboxylic acids, there will be an OH attached to the carbonyl. And the esters, an OR group attached to the carbonyl. Amide, there will be a nitrogen attached to the carbonyl carbon. Acyl chloride, a chloride is attached to the carbonyl carbon. And acid anhydride, two carbonyl groups are linked by an oxygen atom. The last four, esters, amides, acyl chloride, and acid anhydride, these are all carboxylic acid derivatives. Anyway, chapter 16 focuses on aldehydes and ketones. So let's take a look at the nomenclature. For the aldehydes, they will have the AL ending. So we are going to replace the E ending in alkane and put AL as the ending. The nomenclature, the names of aldehyde will be quite similar to that for alcohol, which ends with OL. The ketones will have the ONE ending to replace the E ending in alkanes. So here are some examples. First, this is an aldehyde, and you need to make a note here. Aldehyde functional group will always at the terminus of a carbon chain, because there must be a hydrogen attached to the carbonyl, and on the hydrogen side there will not be any other carbon atoms. So we will number the carbon chain that gives the aldehyde carbon the lower number, which will always be 1. Okay? So we name this compound as hexanyl. You don't have to put down the 1 to indicate aldehyde. By default, the carbonyl of the aldehyde will always be at carbon 1. Alright, so the 1 dash hexanyl, the 1 dash can be omitted. Next example is a ketone. We have a carbonyl inside the carbon chain. There are two carbon atoms attached to the carbonyl carbon. When we number the carbon chain, we want to give the carbonyl the lower number. And this compound will be named as 2-pentanol. Here, 2 indicates the ketone carbonyl is at carbon 2. And you cannot omit the locant number here, because you can also have 3-pentanol, right? How would you name this compound? We have an ketone functional group. We have an alkene double bond. So the carbonyl groups will take a higher priority over alcohols and double bonds. So in this case, we need to give the carbonyl the lower number. And this is how we are going to number the carbon chain. Carbonyl at carbon 1, then double bond at a lower number. So we go clockwise to number the 6-membered ring. And what's the name of the compound? 3-cyclohexenol. So here is the case when we have two endings, the ENE ending and ONE ending. ONE, the ketone, will be the parent compound, so it goes the last. And we omit the E in ENE. So now we have the ENONE ending. And in the ring, the 6-membered ring, carbon 1 will be the carbonyl. So we can omit the 1 on, omit that 1 dash. Okay, so we just call it 3-hexenol, and the 3 here indicates the double bond is at carbon 3. Next example. We know carbonyls will take a higher priority over alcohols' double bonds. But how about a ketone carbonyl and an aldehyde carbonyl? In this case, the aldehyde carbonyl will take higher priority, and we will treat the ketone carbonyl as a functional group. So when the ketone carbonyl is a functional group, it's named as an oxo group, OXO. So basically, double bond O is an oxo group. All right. So the correct numbering, we want to give the aldehyde carbon the lower number, which will always be 1. And then our functional groups. At carbon 4, we have a methyl. Carbon 5 is an oxo, OXO. And carbon 6, we have the double bond. So the name of this compound will be 4-methyl, 5-oxo, 6-octenol. All right, so again, we omit the 1L, the locant for aldehyde. So here is the priority order for the functional groups that we have learned so far. So aldehyde takes higher priority over ketones, which is higher than OH, and OH is higher than CC double bond. And the halogens and alkyl groups are equal, and they are the last. All right. There is another way to name ketones. So previously, the nomenclature we've talked about, that's the IUPAC nomenclature. Ketones can also be named as dialkyl ketone as their common names. The dialkyl ketone nomenclatures will be quite similar to the ether nomenclature when we name ethers as dialkyl ethers. For example, we first identify the ketone functional group, C double bond O, and then identify the alkyl groups attached to the carbonyl carbon. For example, here on the left side, there are 3 carbons. On the right side of the carbonyl, there will be 1 carbon. So the 2 alkyl groups will be propyl on the left side and the methyl on the right-hand side. We name the compound as methyl propyl ketone. Okay. Similarly, we will use the alphabetical order to list the 2 alkyl groups. Okay, this is the same compound that we've talked about before, the 2-pentanol IUPAC name, and the methylpropyl ketone. That's the common name. Next example, IUPAC name 3-pentanol, right? And the common name for the compound. On the left side of the carbonyl, we have 2 carbons. That's an ethyl group. On the right-hand side, another 2 carbons, another ethyl group. So this is a symmetrical ketone. And we can name it as diethyl ketone. All right. So the carbonyl groups are one of the most studied functional group when scientists started to study organic compounds. So there are lots of common names for carbonyl containing compounds, especially those simple ones. And these common names are used very often. So you should know these names, even though I'm not going to test on how to what's the common names for this compound. But if you read the literature and see these names, you should know what they are. For example, the simplest aldehyde, the aldehyde with only 1 carbon atom, it's called formaldehyde. The IUPAC name is methanol. Okay. The second simplest aldehyde, the aldehyde with 2 carbons, is called acetaldehyde. IUPAC name ethanol. The simplest ketone, the ketone with 3 carbons, okay, it's the simplest one. It's called acetone. You've used it in the lab for cleaning purpose and also for the nail polisher remover. The major component is acetone. The common name for acetone, propanol. All right. When the aldehyde group is attached to benzene ring, this is benzaldehyde. All right. So these common names, when you read the literature, you should know what they refer to. Very quickly, let's take a look at the properties of the carbonyl compounds. We know oxygen is more electronegative than carbon. So for the carbon-oxygen bond, oxygen will take the partial negative charge, which will give the carbon partial positive charge. And it's a double bond, so the geometry for the carbonyl will be planar, and the bond angle is about 120 degrees. Both the carbon and the oxygen will be sp2 hybridized, and this is a polar covalent bond. If you compare aldehyde to ketones, the only difference is the hydrogen versus the alkyl group that is attached to the carbonyl. Now previously we've mentioned that alkyl groups are electron donating. That's why alkyl groups can help to stabilize a carbocation. For the same reason, alkyl groups are electron donating, so they can help to stabilize the partial positively charged carbonyl carbon. As a result, ketones will be more stable than the aldehydes. Okay, that's the electronic reason. Ketones are more stable than aldehydes because alkyl groups are electron donating. So in ketones, the alkyl group will stabilize the carbonyl carbon. For steric reason, the ketones will have two carbons attached to the carbonyl, which will make that area crowded. So the reaction that can take place on the carbonyl carbon will be less likely to take place. While consider the aldehydes, the hydrogen will be smaller. So if we have a nucleophile to attack on the carbonyl, it's easier to approach the carbonyl. Okay, so we will talk more about this when we get to the reaction part. Ketones are more stable than aldehydes, which means aldehydes are more reactive than ketones.